anyone try the zoom in? I guess you can hear me. So did anyone try the assuming calculation?
Doctor, you mean the assuming calculate for the example, the questions in example, is it?
Yes.
Yes, we did it. We did it.
Okay. How easy was this? What did you find out? Was there any problem?
The answer is actually the same with the simple formula for mean. The answer we get is same.
Okay. Did anyone ask a problem with that, or do we need to do it in class now?
No, but for the mean, we haven't discussed the group data one, how we need to determine the mean for ungrouped data.
Yes. We will do that today. Anyone with any question? So we go for the grouped mean, the calculation of mean for group data. Right? So let's look at this exercise for the mean for group data set. You look at our table, we have two different data sets, scores and income. So let's try and see if we are going to use mean data.
Doctor, are you sharing a slide?
Yes. Can you see my screen?
We cannot see the slides.
Okay. Okay, I will check. Oh. Can you see now?
No.
Okay. So when we look at this data,
We can see.
Okay, let's try this data now.
Doctor, there is no slide. We cannot see the slide.
Do the calculation. Are we okay with that?
Doctor, we can't see any slide and yeah.
Okay. So here, let me see if I have this data here. Can you see my Excel sheet?
Doctor, we can't see your slides, your Excel, we can't see. Have you shared screen?
Yes, I've clicked share screen. I think, let me check. Yes, share screen. Yeah. Okay. Let's do it. Let's go again. Share screen. Okay. Now?
Yes.
Okay.
Yes, we can see.
You can see the Excel sheets now. What about this slide? Can you see the slide?
Yes. We only.
Yes, doctor. Yes.
Excel only.
Okay, you can
see the Excel file.
Excel file. Okay. I want to see. Okay, let's look at this Excel file. Let me try and make it a bit bigger so that you can see very well. Okay. I think it's visible to you, right? Can you see the figures?
Yes, Doctor.
Yes.
Okay. Right now, what we need to do is, because this is a group data, we first of all find a kind of midpoint of this data and fill it in the column where I put midpoint. So when we put midpoint, how do we get the midpoint? Midpoint, you add the lower limit, the upper limit, and divide by 2. So for here, for this one, what will be the midpoint? The midpoint is 0 plus 9 divided by 2.
4.9 and 4.5.
Correct. So the next one will be 14.5, if I'm not mistaken, because the interval is 10. Do we understand? 10 plus 19 divided by 2. Do you agree with it?
Yes, Doctor.
Yes.
So
Yes, Doctor. Yes, Doctor.
because there is 10, the interval, the class interval is 10. So we begin just be adding 10, it makes it easier to get to what we're going. This for 24.5. The next one will be 34.5. The next one will be 44.5. 54.5. 64.5. 74.5. I hope you are following this. 84.5. 94.5. So this will have been 104.5. So are we clear with this? Now then, this midpoint is representing our x, y, the number of students is representing our frequency. So we need to find fx. So now fx will be this multiply by this. I hope that one is clear. So the fx for first column is 36. Is anybody cross-checking?
Yes, Doctor.
Okay, it's correct.
Yep, correct.
So we draw down just to make it faster. But remember, in exam, you are going to do it with your calculator. So in exam, you are going to do with calculator. So it's unfortunate we are not on face-to-face. It will have been calculated in the classroom where everybody will participate. So getting the fx, now make it simpler. We get our total frequency and get the summation fx. So it will be easy for us to arrive at mean. Here, what's the total frequency? Adding this together, what's the total frequency? And adding this together to give us the total frequency. I hope it is clear to this level. Any question? Any question?
No.
Okay. This is still elementary. So our mean we equal to summation fx insert symbol okay, summation fx, which is summation of this divided by frequency. So this gives us 55.78. And maybe let's edit this to 2 decimal points. Edit cell. 2 decimal points. Okay. And this gives us about 55.79. Do we understand this now?
Yes, doctor.
Finding the midpoint. You know, what we did was to find the midpoint of this scores range and multiplying by their frequency. Then we get our summation fx all over the frequency, total frequency. Straightforward, I guess. So just as we do on the ungroup data for assumed mean, now that we have a midpoint, we can get an assumed mean. Can we do by adding another? Okay, we can use here as assumed mean. You still have space. So if you want to go through assume mean method, now we can assume a mean within these midpoints. And when we assume mean from these midpoints, we will be able to get a deviation from the assumed mean. And from there, we can calculate our mean. So if you want to go by assume mean, which one do we assume as assume mean? Which one of these midpoints do we assume as mean? Anyone? Is anyone suggesting?
34.5.
Okay, 34.5. Okay, 34.5. Okay, 34.5. Okay, so let me fill this cell, let me color this cell so that we know our assuming is there. Let me see, can I fill this cell with this? Okay, something. Okay, assuming is 34.5. Okay, 34.5. So now that we have assuming, our assuming A as 34.5. So we work deviation from assuming as A minus X. So which is D. Is that clear?
Yes, doctor.
Okay. So A minus S or X minus A, which one? I think S minus A minus S, yes. X minus A. Deviation from assuming. So let's go. So taking this one out of this, equals, this is our X. I think should be X minus A, yeah. I think X first come first, or whichever way, let's go first. A minus X, this is A minus X, and this one is having dollar sign. Let's do my dollar sign. Okay. Is that right? Okay. Yeah, let's go on. I just want to be sure. And I copy the same thing around all around. Okay. So like here, it's X minus A or A minus X. I just want to be sure of the dimension. Either X minus A or A minus X. Let me see. Then we multiply the deviation by the frequency, which is this. Let's try. Deviation multiplied by frequency. Okay, let's go. Okay. This should be X minus A. So, and this will be X minus A. So we have plus X minus A, and this one has dollar sign. I think, yeah. So let's try. So this, we get the total here now. Control V. Yeah, 59620. Then our formula is, the formula is A, assuming plus total of FD divided by F. Okay, this is summation FD. Okay, let me go and copy the formula. Control C. So I think this is the formula I want to use now. So summation fx all over this is the summation now. We have A, which is 34.5. Let's quickly try. what is the number of the cell? F2. So this is F2, F2 plus open summation these divided by total frequency. That's shit. Okay. Okay. So this is still 55.79. If we approximate 2 decimal place, 2 decimal point of view. Okay, 2 decimal place. Okay. So we can see the answer is still the same thing. So is this one clear now? That even when you use a zoom in, or you have a weight of, or use midpoint, you are still going to get the same thing. Is it clear?
Yes, doctor.
Okay, and this is how you do when you are doing group data. If you want to find the mean, you find the midpoint first, then you apply the normal formula. Get the summation, get your x multiplied by what? F, and when you get it, sum everything together and divide by the total frequency. So with this, I think we are okay with group data calculation now. So I'm just using this as elementary so that we know what are the basic things we do in statistics. And because you're going to be tested on this or manually, you do it yourself. So all this, we have gotten a lot of econometric programs, applications that you just ask for mean and they give you mean straight and you will not need to go through this stress when you are in practice. You have applications to do that. So we can now go to median. So can you see the slide, or I start sharing slide again?
We still see the Excel.
Okay, you are still seeing the Excel. Okay, I will select the slide now. Okay. Share my contents. I hope the slide come up now.
Yes, doctor.
Okay, so we can just look, now we know how to calculate mean for group data and non-group data, and how to use a zoom mean. So let's look at the median. The median represents the middle observation in the data set. So if I want to observe the height of everybody in the statistics class, and the height varies. So if I arrange everybody according to their height, somebody will be in the middle. And the height of the person in the middle is what is regarded as median height. So it is for data collection. When data have been collected, or observations have been recorded for a particular variable. So we want to know which one of these scores or the values are or is or are in the center. Because you might find a situation why two observations fall to be in the center, especially for even scores. And when two fall into the center, the average of the two, add the two together and divided by 2, give us the median score. But when we have a single observation falling into the middle, then that observation is the median value. So from this this illustration, when we are to find the median of the score below, If you are seeing my slide very well, let's look at the scores. How, because the illustration, I have 35, 36, 37, 34, 37, 40, 42, 42 again, 42 again, 45, 45, 46, 47, 49, 49, 51, 51. This is a set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is called, this is 15 observations. So which observations fall into the middle? When we divide 15 by 2, we get 7, right? That means after 7.5, that means the value after 7 observation is the median observation. So I count from 35, 36, 1, 2, 3, 4, 5, 6, 7. 42 makes 7. Then the next one after the 7th observation is 45. So, and after this, I have another 7 observations. So the median score or median value is 45. That is clear, right? Is that clear?
Yes, doctor.
Yes, now let's find the median of the score below. The scores in the red. You can see that the scores follow the same thing with the illustration, but with added values. And we have 51, 51, then we have 53, 55, 57. So how many observations do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here we have 18 observations. What does this tell us? If we divide 18 observation by 2, looking for the middle value, then we have 9 each side. So when we count the 9, we are saying the next one of the 9s should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th one is 45. Then to the other side, another 9th one, when you are counting from the end, is 46. Because 2 values fall into the middle, the average of the middle of the 2 will form our median score. Is that understood? Because we have this value, 45 here, and this 46 to be the median value. Let me try to change the color so that we understand. So these two observations are in the middle. So the average of the 2 observations will become the median.
Understand.
Okay, so median equals 45 plus 46. Everything divided by 2. And that will give us 45.5. Am I right?
Yes.
Yes.
Yes. And this give 45.5. So this is, you can see from this observation, there's no observation called 45.5, right? But when we calculate the median value of this scores, the entire scores, we get 45.5. So it's not as straightforward as where you just have one observation falling into the middle. So the median value, the median is always looking for the value that will be ascribed to be the median score of in a set of observation. Understood? However, for group data, there's a formula to calculate the median value. when we have group data, we can look at the group that fall into the middle line. And when we get that, then we apply this formula, which says if the scores are arranged in ascending form, that's from the lowest to the highest, then when we get to the median class, the lower limit of the median class will be added to this expression. Half of the entire frequency divided by the frequency of the median class multiplied by the class interval. So let's illustrate this. And let's illustrate this by looking at this data set. So look at our data set here. We have to look for the median class. When we look at the score side, the median class is 60 to 69. And how did we get that? The total frequency is 280. Then when you divide the total frequency by 280, what did we get? 280 divided by 2.
140.
140, correct. So when you look at your cumulative frequency, which score, which class, or which class interval, or which score group fall within 140? Where do we get 140? You will see that we end at 134th observation. And after 134th observation, those who scores 60 to 69 starts and ends in 213 observation. So that means between 130, our 140 will fall in the class of 60 to 69 scores. Is that understand?
Yeah.
Did you understand that analysis?
Yeah.
Good. So if we understand this, that means our median score is going to be between 60 to 69 among these 79 students who are scored 60 to 69 mark range. Doing the same thing for the income, we discovered that the total frequency there is 155. And if 155 is divided by 2, we get 77.5. 77.5. Now, if you get 77.5, that means we are looking for the 77.5 score, which will be in the middle. And we find that we will get that on the 4,000 to 4,999 range. Is that understood too?
Yes, doctor.
Yes, good.
Yes,
So now,
doctor.
so what we do is now to apply our formulas. So we apply our formulas to get the exact score or exact income that will be regarded as our median income. So can we do that now? Looking at this formula. So let's see. Which one is okay? Let's duplicate this one so that we'll work on this. Okay. Let's work on this. Now we have to use this formula. P is total frequency divided by 2, half of the total frequency. So if you do that, then we are going to have, where do I write? Is anybody calculating it now? Is anyone calculating the median? Okay, let's get the values from this table for this. Our L our median should be L. So for the scores, we said the class that is falling into the median class is 60 to 69. So our lower limit is going to be 60, which is the lower limit for the class of the median class. 60 plus, I will write the expression, I know somebody will calculate for me. So this is 140, our P is 140 divided by the frequency of that class. Frequency of that class is 79. Can we get that? Number of students, 79. 79, then multiply by the class interval. What is the interval of the class? 0 to 9. That's 10. Okay? Now, can somebody work out this expression and give us the answer? Is anyone trying it?
Doctor, can you move your cursor? We can't see.
Okay. Oh, okay. Let me build it. Let me make it that thing bold. Perhaps you can see better.
77.72.
This is. I just want to confirm. This is 79 dividing 140. 140, yes. Calculator.
77.72.
Okay, I'm coming. 140. 140 dividing. That should be cumulative frequency of that class. Sorry, that should be cumulative frequency of that class. 79 should not be, it's 213 that we use. 213. And the formula is cumulative frequency of that class. That's the essence of doing cumulative frequency. Sorry. Do you understand that?
So the slide in front, we need to amend, right?
Yes, I'm already amending it here.
Okay, okay.
So cumulative frequency of that class. So, and this is 140 divided by the cumulative frequency, which is 213, plus, this is multiplied by 10, multiplied by the interval 10, equals plus 60, okay. 66.50. Yes. So what did we get?
66.57.
6.57. Okay. So what it means is that the median score fall between 60 and 69, and that's we got 66.57. That means closer to 69, right? So within this, out of these 79 students, we will have a student that score either 66 or 67 or 66 point something. So that will be the median class. So I want us to quickly look at using the upper class. Let's see whether we are going to have a difference in the result or what will be the margin of difference. By using the other formula down there, we say U instead of L. U means upper class, which is 59. So it's just changing upper class to 69 and look at, let's see what the difference will be. 69, that will be 69 point minus, okay? 69 minus 140 again, 140, cumulative frequency is, at that place is 213, yes, divided by the interval. Yes, there must be questions here. So instead of 66, that would be 63 or something.
62.43.
Okay, 62.40. $62.40. Okay.
43.
43. Okay. So, yeah. So here you can see the difference that arises depending on which score is taken, either the lower limit or the upper limit. So if this arises, that is why it is good to specify the formula you adopt when you are working. For example, if somebody is adopting the lower limit, you state the formula. If you're adopting the upper limit, you state the formula. And this will give us, we make sure that the result is not too far away from each other. But this is giving us that an estimate of the median class still fall within 62 and 66 point something. Does my explanation clear it? Oh God, what kind of it is this? So let me put this one here so that it will be visible. I think it's visible now. Any question?
Yes, doctor. I'd just like to quickly ask, so when we actually do a question for median, for group data, do we have to use both formulas or just one?
No, just one. Just state the one you use.
All right, thank you, doctor.
Yeah. Because if it is a descending order arrangement, so if you are using the upper class limit, the sign changes, minus. If you are using the lower class limit, the sign is plus. That is just the difference between the two formulas. Because by the total frequency, you are looking for the middle score. And the middle score will lie between 60 and 69. So because they are not absolute figures, because they are in a range, there's tendency of having decimals and little differences. depending on which one you have adopted. So you state whether the formula first shows lower limit so that your marker will look at lower limit. And if you are choosing the higher limit one, your marker will look at the upper limit as well. Okay? Any other question?
Doctor.
Okay, that's okay.
Doctor, actually you learned this during our secondary school.
Yes.
But the formula is a bit different. So which one should we follow?
Okay, I will check.
A bit different, a bit different.
I will check the difference. Okay. So, okay, tomorrow during, Thursday is tutorial, right? I will bring it up on Thursday during the tutorial to see the difference, okay?
We try both method and we get different answers. So maybe we can say that the formula is different from what we learned before.
Okay, so I'm sorry. It's funny, yeah, it's back. Okay, my internet is back. So we check it on during the tutorial, okay? So let's quickly look at the modal class before we end this class. Mode generally is the most frequent value, the most one that is highest frequency. So when you look at the mode, we just want to look at which one is the most occurring. If we have a data set that is giving us a particular data, a particular observation that is occurring all the time. If you are looking at data like, let's say gender, and you are seeing either male coming on more all the times. So what is the highest observation, male or female? That is what the mode is looking for. But if these data are just on group data, it is easier to identify this one is the modal class. Even when it is grouped, a frequency will determine which one is the modal class. If you look at this data, we see which one is occurring all the time, most of the time. We look at the data. Here we have 1,900 appearing 4 times, 3,500 appearing 7 times. So the data that appears more time is what we regarded as the modal class. These are basic secondary school set statistics. Problem in that, to check. So, but if it is a group data, we look at which data is occurring, which group is occurring higher, then a formula is adopted. So, and if formula, we look at the frequency of the modal class, frequency that is preceding the modal class, the frequency of the modal class minus the frequency of following class, and class intervals. So from this formula, we have MO equal to L plus D1 all over D1 plus D2 by interval. D1 is representing the frequency of modal class minus the frequency of the preceding class. Then D2 is representing the frequency of the modal class minus the frequency of the following class. So if you look at this data, I think, okay, good. For this course, 79 remain the modal class because that's the highest. So we look at the frequency of the modal class, the frequency of the class before the mode, then the frequency of the class after the modal. And that is inputted into a modal, the mode formula here, multiplied by the class interval as usual. So if we add this to the lower limit of the modal class, which is 60 here, then we will work out what is the modal class. So is that clear? Do we understand, so that we check for the modal class? I'll look at this. Hello? Hello? Any
Yes,
question?
clear, doctor.
Yes, doctor, we can hear you.
Okay. Oh, I thought I lost you. So with that, we can look at the modal class quickly, because I want us to finish with the modal class before we end the class today. Because the next week will be measure of dispersion, standard deviation, variation. But during the tutorial this week, we'll finish iron out anything on this. On the median, I will check again. Okay. Oh. So thank you. I've seen. I saw the thing on the chat. I will check for it. I think there's an error on my formula. I will cross check. Okay. I will cross check for that formula. Then we'll use it again on tutorial class on Thursday. So for the modal class, can we quickly look at it, how we can apply it for this table? Yes. Any response? Hello.
Yes, doctor.
Okay. Yeah. My internet is a bit, at times it's lower in brightness, so that's why I'm trying to ask. So let's quickly apply this. Control C here. So now, if we identify the modal class to be this, because 79 is having the highest occurrence. So the formula here is saying that D1 is the difference between the frequency of the modal class minus the difference of the preceding class, and the frequency of the preceding class here is 32, while the frequency of the class after is 34. I think with this information, we can quickly substitute and see what we get. Here, our mode should be, our lower limit is 60, right?
Yes.
Still, plus D1. We say D1 will be difference between the modal class frequency and the frequency preceding. This is 79. I'm just picking the figure here, 79 minus 32, okay, divided by D1. 79 minus 72 will be, 79 minus 32 will be 50.
47.
47, okay, 47. So in that wise, this is 47. So this 2 is 47. 47 plus the difference between this, okay, 34, just 2. That will be 45. D2 will be 45, if I'm correct.
Yes, 45.
By 10. All this by 10. All this by 10. So when we work this one out, we can try and have the final figure. Okay. Is this still correct? Okay. This divided by this multiplied by 10. No. There's still a bracket here. Bracket here. From the bracket here. And so this multiplied by 2 to this. Yeah. 47 divided by, this is 93. 47 plus 45 will give 92. Is 47 divided by 92. Forty-seven.
0.51.
Okay. 47 divided by 92, 0.51 multiplied by 10 equals plus 60. 65.12. Okay, this is 60 plus 0.5. Is it 0.51 multiplied by 10? If it is correct, and this is 65.1. So this gives 65.1 for the mode. Is anyone cross-checking? Yes, it should be correct.
Yes, correct.
Okay.
Correct, Doctor.
Yeah. So this is the application of this modal formula, long formulas. So still, as I said, in the practice or in the real world, there are all applications available to do the calculation. That we just get the main median mode and everything for us. So this is just the 3 central measurements that we need to look into. Another one that I want us to look into is just the range. And the range, as we know, it is just the range between the minimum score and the maximum score. So it's just a range. We cannot call it a measurement. It's just giving us an idea of the spread of the observations. Any question now on this, on mode?
No, doctor.
Okay. Okay. So if there's no question now, the next thing we have to do in the class in the next week will be measure of dispersions, which has to do with variance as well as the standard deviation. Then we look at the points, the percentiles. So we look at the dispersion of the scores from the mean or from the central tendencies, points, and net observations and quartile observations. So meanwhile, on Thursday, we'll try and do more of, I will send in some questions on measure of central tendency, mean, median, mode that we can work on if need be for the tutorial class. So that I'm going to check for the median formula again so that we'll look at it together in the class. Is that okay?
Yes, doctor.
So any further question? Because it's supposed to be so that we interact more. We still have some minutes left to interact.
So mean, median, and mode like this will be tested in final exam.
Yes.
So we need to show our calculation, right?
Yes.
The formula also.
Yes.
Do we need to draw again the table?
Depending on the questions, if you are to represent some data, maybe graphically or on table form, I don't know the format the test or the exam will take for now. But it will involve the test of the knowledge that we know the basic principle behind statistics. So it may be hypothetical that we give some informations about real estate data outside, and you are asked to advise based on your analysis of the data. But when we get there, because we will still do some correlation, we'll still do some logistic regression. You know, we have a lot of topics to cover. But perhaps if this one comes in the test, maybe the others that we have not, that we're still going to do, will be the one we will see in exam, depending how much, because we need to cover the syllabus first. Okay? Any other question? Modu Asman, yes, what do you want to tell us?
No, doctor, no question.
Okay. So, any further questions? Okay. Mark your attendance on Spectrum, please. So, have you all marked your attendance on Spectrum?
Yes, doctor.
Okay. And you were able to do it, okay? So if there's no question, you may leave the class now. or if you still have some discussions, let's have it. We still have about 20 something minutes for the class. So if there's no other question, we can handle the class. Thank you for being here today.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Yeah.
Thank you, Doctor.
Thank you.